First thing we're going to talk about is sklearn. Sklearn is a library that is used for machine learning. Its full name is actually scikit-learn, and it's a library of models and things. It's really more for learning, but sklearn has this awesome advantage that you can understand what's going on really well. So it's normal to start with sklearn, and it has excellent documentation. It's really easy to get started with. In fact, we'll be able to build an sklearn model in maybe 6 lines that can actually be a working machine learning model. The first thing we're going to want to look at is predictors. One particular type of estimator is called a predictor. So a predictor is what it sounds like. It takes a big data and it builds a prediction function. So these estimators are all going to have the same basic things. The first one is fit. So the fit method is going to take 2 arguments. These things that are inside the parentheses are arguments. These are things that are being passed to the function. The first thing we're going to pass in, what are called observations or examples, and each observation will have features which are like variables. So X is going to be the set of training data, and there will be 1 row for each observation in our training data set. And then there will be 1 column for each feature, which is like a variable that you're feeding into it. And then Y will also be training data, but it will be the corresponding output for each row. And that's called the target. So features are what you're going to be using to predict, and the target is whatever you are actually predicting. Imagine that you knew someone's height and weight, and you were going to try to predict their income based on that. So in that instance, what you would have, your X here would be height and weight, and then you would have your 0th observation, your 1st observation. So you'd have all these different people, and you would have their height and weight. And this part would be the X part of the data, and you would actually be separating it out. So this would be X of whatever you are actually using as the input to that you would be predicting from later. And then if you were using height and weight to try to predict income, Y would be the income. These would probably initially start out as one thing. You'd probably have just one spreadsheet or CSV file that had all of these together. Your job would be to separate them into what am I predicting based on, and then what am I actually trying to predict from that. You fit, you have your X and your Y. Then you can make predictions, which would be with a predict method, and that would give you the actual prediction. There are a couple of other methods that are always going to pop up. One of them is what's called score. So score is a way of telling you how good your model is. But I'm going to go ahead and tell you the mistake that people make is they treat score like it's a video game score, and you're trying to get a higher score all the time, and that's not how it works. Score is one useful piece of information. You really need to understand whatever scoring function is being used, and often if you're doing this in the real world, you're going to be creating your own scoring function. Scoring function, you have to think about what are the risks of false positives and false negatives, and are there some types of data that are more important to track than others? Okay. So if we were building a rabbit classifier, it may be that we're okay. Like it's not that big a deal if every once in a while a picture of a squirrel gets through and gets called a rabbit. But it's a really big deal if a picture of a rabbit, that has been killed gets through. That's going to be an issue for our users. So we could create not just a score based on accuracy, not just like what percentage did you get right. We might say that's something that comes later. First, we're going to ask, did you let any disturbing or inappropriate pictures through? We could build a 2-step process where you better be not letting anything that we don't want let through, and after that, we'll worry about what percentage you got right. And that would be a custom classifier because we would need to have our disturbing images specially labeled in our data set, and we would need to check them one by one, and we would have to write that. There's no way to specify that in the pre-rolled sklearn framework. So just using a score by itself is something you would not typically do at this stage in like real world machine learning, but we are going to use it to give us some information and insight into how our models are behaving. Any questions about that?